We've all seen these pictures of galaxies from space taken from the James Webb Telescope revolving around the internet. These unimaginably beautiful pictures are the result of $10 billion and 25 years of intense research. But what really is inside the Space Telescope that makes it worthy of costing $10 billion? Well, we'll be answering this question in today's video at TechWave. Before we begin, hit that like button and subscribe to our channel for more tech videos like these. The James Webb Space Telescope project started way back in 1995 by the National Aeronautics and Space Administration, or NASA. The James Webb Space Telescope is an infrared space observatory launched to examine and find answers to the history of the universe, planet formation, and beyond. This observatory is said to be one of NASA's greatest creations, with substantial space instruments that are said to be better and more improved than the previous projects. In addition, it's said to be one of the largest optical telescopes launched in space, with the capability of targeting near-infrared and mid-infrared rays that allow it to visualize objects that are light years behind. But here the question arises, why was the James Webb Space Telescope needed? The James Webb Space Telescope is the successor to another great observatory, the Hubble telescope, which was sent to space for a similar mission in 1990. The Hubble telescope provided some breathtaking images of galaxies, but they weren't clear enough to identify the different planets and galaxies. The photos had massive dust clouds and cosmological redshifting that appeared because Hubble couldn't penetrate through the dusty regions of space. Now, NASA had a solution to this problem with the James Webb Telescope, which targeted near-infrared and mid-infrared rays that could easily penetrate through the dust clouds and capture galaxies with high redshift. The primary goal of the observatory was to combat the difficulties that astronomers had while studying the early universe. From the pictures released by NASA a few days back from the James Webb Telescope, we can tell that they've successfully resolved them. So now we have a clear idea why the James Webb Telescope was needed. So let's talk about the ideal conditions it needs to operate to its full capability. To ensure that the observatory works properly and captures the image as clearly as possible, it needs three things. Number 1. A large mirror. A large mirror is crucial to the telescope to work properly as it can maximize the infrared rays coming at the telescope to be processed into an image. The bigger the mirror is, the more rays will enter the instrument, creating a clearer image. For this particular reason, the mirror in Webb was manufactured 9 times larger than that of Hubble. Number 2. Extremely cold temperature. The mirrors in the James Webb Telescope are made from a unique metal called beryllium, which maintains its shape at extremely low temperatures. The temperature must be as low as -227 degrees to prevent the mirrors from contracting. Maintaining this temperature in space is easy if the body is far away from the rays of the sun. Number 3. Clear line of sight. The James Webb Space Telescope will be capturing images billions of light years away, searching for the first galaxy and planets. To study galaxies that far, the observatory needs to have a clear line of sight without interference from other bodies. If these conditions are ideal, then the telescope will have no problem extracting the clearest image of the first galaxy and galaxies far away. Now, with that out of the way, let's discuss in depth what's inside this $10 billion telescope and how it was made. Now, if you're enjoying this video up till now, please subscribe to this channel for more tech-savvy videos like this. The $10 billion James Webb Space Telescope is divided into 4 major components that allow it to operate smoothly in space and capture high-quality images of galaxies light years away. Now, these components have been studied and perfected meticulously by the team over the course of 2 decades to ensure that the telescope fulfills its mission. Let's now discuss in detail what each component is and the role it plays in the functioning of the telescope. Component number 1. Optical Telescope Element, or OTE. This component of the telescope is said to be the heart of the telescope that sets it apart from every other space telescope ever made. Now, the optical telescope element of the Webb consists of 3 mirror anastigmat lenses that enables the observatory to click the sharpest and cleanest image of the galaxies. Now, for those of you who don't know, it simply means that the rays bounce 3 times on 3 very different mirrors before hitting the instrument and clicking the picture. The primary mirror in the telescope is made out of beryllium metal that is coated with 24-karat gold to maximize the reflection of infrared rays. We'll discuss how it works in a little bit when we discuss its working. Component number 2. The Integrated Science Instrument Module, or ISIM. The Integrated Science Instrument Module, or ISIM, is part of the telescope where all the magic of clicking the picture happens. This instrument module consists of the near-infrared camera, near-infrared spectrograph, mid-infrared instrument, and fine guide sensor. All these components work in collaboration to help astronomers study the galaxies. Component number 3. The Sun Shield. Beneath the mirror and instrument lies the sun shield. The sun shield was made out of 5 layers of thin plastic coated with metal to keep the telescope in shadow. The tennis court-sized shield installed in Webb would block out any excess light from the sun, giving the telescope a clear line of sight for better visuals. The infrared light can be interpreted as heat, so the sun shield was engineered carefully to ensure that the mirror is safe from all heat sources that can hinder the image. Component number 4. The spacecraft bus. The spacecraft bus of Webb is a component that carries and supports all the other elements of the telescope. The spacecraft bus is responsible for powering, communicating, controlling altitude, and onboarding computer power. The rocket jets installed in Webb help maintain the orbit and sometimes unload the reaction wheels. Now, these reaction wheels help in effectively utilizing the fuel of the observatory. They collect the angular momentum from the sunshine and help point and orient the spacecraft without using the rockets. Since we're now aware of the components inside the James Webb Telescope, let's discuss how the telescope works and captures images. The infrared rays bounce on the large concave mirror that collects the majority of rays and focuses it on the smaller secondary mirror. This gives the smaller mirror more light than directly facing the rays. The rays from the secondary mirror are then sent to a tertiary mirror that compensates for the telescope's movement and sends the rays to the sensor that captures the image. Behind the mirror rests the ISIM responsible for taking the images. As we've discussed, Webb needs a clear line of sight with no interference from other bodies. So where exactly was Webb launched? It was sent to the L2 Lagrange point. To reach the L2 point, the James Webb Space Telescope traveled a distance of 1.5 million kilometers, where it can rest at a stable position in space. By staying at the L2 point, the observatory will orbit around the Earth and block any excess light from the sun. Webb was launched on the 25th of December 2021 and reached L2 on the 24th of January 2022, traveling for about a month. After almost 6 months since its launch, NASA released the first images taken from the James Webb Space Telescope. These images are proof that the project was indeed successful. Compared to the images taken by the Hubble telescope, we can clearly tell that the images from Webb are sharper, cleaner, and more detailed. Moreover, these images have revealed some of the most significant discoveries in the history of astronomy. The first image, which look like dust mountains, is basically the Carina Nebula, which reveals previously invisible areas of a star's birth for the first time. The second image is called Stephan's Quintet, which represents the 5 galaxies that are about to collide. The image from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. The third image is of the Southern Ring Nebula. This star has been sending dust cloud signals for thousands of years, and with the latest image from Webb, we can confirm for the first time that it is indeed cloaked in dust. The fourth image of the Webb telescope, called the WASP-96b, represents a sign of water along with traces of clouds and haze around a hot, puffy gas planet. The fifth and final image released by Webb is called the SMACS-0723. This is the cleanest image of the first galaxy, 13 billion light-years away. Well, that's all about what's inside the $10 billion James Webb Space Telescope and the images released taken from it. Let us know in the comment section whether this telescope is worth $10 billion or not. Also, while you're on the way down, don't forget to like this video and subscribe to this channel for more tech videos like this. That's all from our side. We'll see you in the next video. Till then, have a fantastic day.